All right, I'm going to try and record this, but I keep having announcements come on behind me. So if an announcement comes on, we're just going to let it ride. Yesterday, we focused a lot on place value and digit. And place value, if you remember, that word place means location, where it is. And so whenever you're looking for the place value of a digit, you just want to know where in the number, where in our place value parking lot that digit is parked, because that's very important information. Your answer is simply where it is, and it ends with the word place, like the 100,000th place. But we talk that kids often confuse place value and value, and that's because they share that same word of value. So today we're going to focus on the meaning of value, and then we'll kind of be able to know the difference between the two of them. So the word value is something that you actually use in the real world. So when you think, what does the word value mean to you? Like if I were to say to you, for example, that my car has a value of $24,000, that really means what my car is worth. So in math, value, when we're talking about the value of a digit, the value is how much a digit is worth, okay? Now, there are two things that can help to determine the value of a digit. The first is the digit itself. If it's a 5, it's going to have a different value than if it's a 7, okay? But the other thing that's also important when finding the value is what place value that digit is parked in. If that digit is parked in the tens place, it's going to have a different value than if it's parked in the hundreds place, okay? So if you remember, we have 10 different digits, and we know that the further we go to the right, the more that digit's worth. Obviously, 9 is worth more than 3, right? We know that, okay? But when it comes to place value, there's our place value parking lot. We know that we always park first in the ones place. And as we move to the left in the place value parking lot, those spots are worth more. So if a digit is parked in the 100,000s place, it is going to be worth more than if it is parked in the tens place. And so now we need to take those two ideas and put them together. So there's two different strategies that I'd like to introduce for value. The first one, if you look at the letter V in value as a reminder, it kind of looks like a downward arrow. And so I use this downward arrow idea to help with strategy number 1, where basically we pull down the digit straight down like an arrow and fill in the rest of our place values to the right, because we're not allowed to park in the middle of the parking lot, with zeros. And the result would be the value of that number. Now, strategy number 2, I like a little bit more. I use an upside down V, and that helps me to remember that digits are important when finding the value, and the place value is important when finding the value. And we take them and we multiply them together to find the value. So let me give you an example of each strategy. Here's strategy number 1 with that downward arrow. Now the digit is extremely important, that we're looking for, in this case, the value of the 7. So we're going to pull that 7 straight down. But if this whole thing is a place value parking lot, we know we're not just allowed to have a car parked anywhere we want. It has to start the parking lot back in the ones place. And so once we pull down that digit, because it's very important, we want to make sure that it stays in the same place value. And to do that, we're going to fill all additional place values to the right with a digit, but we're going to fill it with the digit of 0. And so we end up saying that that 7 in the number 578,395 has a value. It is worth 70,000. Why? Because it's a 7 and it's in the 10,000s place. It's worth 70,000. And I think about this with a different strategy as well. Let's do the same question. What is the value of the 7? But now we're going to use the upside down V. And remember that digits, the digit is important and the place value, and we're going to multiply them together. So the digit is a 7. The place value, if you're not sure, this would be the ones period. This would be the thousands period. And since it's the second spot, it's the 10,000s place. I'm just going to multiply them together. 7 times 10,000. Well, that's like giving you 7 $10,000 bills. That's 10,000, 20,000, 30,000, 40,000, 50,000, 60,000. That is 70,000. That 7, because it's worth 7 groups of 10,000, is worth a total of 70,000. That is the value of the 7. Okay. Now notice we had the same answer with both strategies. So if you were in the classroom, we would be doing some more examples on the board. Obviously, we're not, but you can rewatch this video and look back at those 2 examples again. All right. So here, I'll just show you. If I have what is the value of the 5, if we're using that upside down arrow, we know we're focusing on digit and place value. So the digit is a 5. The place value of that 5, it's parked in the 100,000s place. So if I have 5 groups of 100,000, that would be a total of 500,000. So that 5 is worth 500,000 because of where it's parked. Now, if you notice, there is another 5 in this number. It's over here. And because it's parked in a different place value, it's going to have a totally different value. We still have the digits of 5, but the place value is the ones place. So it's worth 5 ones. Well, 5 ones is 5. So even though we have the same digit twice in a number, because they're parked in different place values, it's going to have different values. It's going to be worth a different amount. So there is a Pear Deck activity that you will be completing to kind of test out both strategies and determine which strategy for finding value you prefer. So that's what we're going to be working on next.